Hold on.
Oh, and Shelby just interrupted our video. But here we are again with the Mckee calculus, starring Timothy Mckee. Here we go.
Alright, we stopped off after number 8. Number 9 gives a little bit of information. It tells us that the integral of some function from 0 to 5 is 9.
Sorry about that.
And the integral from 2 to 5 is negative 1. If we think about this like areas, this area is negative 1. The total area from 0 all the way out to 5 is 9. Which statement is true? Well, it seems to be asking us about the area of this little region here. The integral from 0 to 2 of the function must be 10, because that's the bell. Because 10 minus 1 gives us 9. Number 10 looks much more difficult than it is. It gives us lots of information about the original function, the first derivative, and the second derivative. We're going to use these things to solve it. So let's begin with item 3. The second derivative at 0 is negative 10. And it might not be apparent why we're going to use that yet, but let's go ahead and figure it out. The first derivative is going to be 3ax squared plus 2bx plus c. The second derivative is going to be 6ax plus 2b. Well, I know that when I plug 0 in for x, my answer's got to be negative 10. So when x equals 0, I get 0 plus 2b equals negative 10. b then must be negative 5. Because 2b is negative 10 divided by 2, b is negative 5. Now that we know that b is negative 5, I will again use the second derivative, and 6 times a times 1, using the 1 here, plus 2 times b must equal 2. Solving this, we get 12 is equal to 6 a's. This shows us a must equal 2. We'll wait for the boys in the back to be quiet. Jamie, Troy, go home. The bell rang. We're making a video. Look, they're still talking. Can you believe it? All right. Moving on. Now we've solved for a and b. Let's use the first derivative to find c. We're going to plug in 1 for x, 2 for a, negative 5 for b, and set the whole thing equal to negative 1. That will tell us c. Once you've done that, back to the original function with everything, plugging in 1 for x, and all these for a, b, and c needs to equal 4. Use that, solve for d, plug it in, and sum them together. Sorry, I'm not going to do the whole thing here. I just don't want to waste that much time on YouTube. Number 12. Alright. It's a big integral problem. The first question is, can we use algebra to simplify this in some way to integrate it? No, we can't. So it's got to be a u subproblem. We'll let u equal 9 minus 5x squared. du then is going to be negative 10x. Rewriting the problem, we're going to substitute in now the square root of u du. Now, the nice thing is our problem has an x in it, and when I write du, it includes this x. However, there's a negative 10 that also gets included here that is not part of the problem, so I'm going to cancel that out here with a negative 110. Integrating this, per usual, we'll have a negative 1/10 times the integral. I'm going to change this around and make it an easy power rule. U to the 1/2 instead of square root of u. Integrating that's going to give me negative 1/10 times u to the 3/2 with a 2/3 in front. Obviously, if u to the 3/2 has got to be a 2/3 in front. Simplifying this a little bit more gives us negative 1 over 15 times 9 minus 5x squared to the 3 halves. Don't forget you must have a plus c because this again is indefinite. And that's the end of those.
Okie doke. Thanks for watching, everyone. See you shortly.